Okay, so as my class is talking about spiders and other creepy crawly stingy things, we are back for Mr. Jeffrey's Algebra 2, trying to clean up some stuff because apparently I had the COVID last week, and even though that I did put stuff in the Schoology, a lot of people didn't check it out. So, or they just, I'm their math security blanket and they just need me right beside them to do stuff. All right, so here's what's weird. You know, there's these end behavioral functions. And by the way, if you hadn't done so, hit the like, hit the subscribe, and hit the bell. Don't forget to leave a good comment. So we're looking at the ending. Hey, I have one ear that works and I can hear everybody. Y'all need to tone it down just a little bit. Where's that volume button? Where's that volume? Okay, so now here's kind of the main stuff. And I want to teach you how to do this. All right, if the degree is odd and the leading coefficient is positive, it's going to look like this. Okay? If the degree is odd and the leading coefficient is negative, well, it should look like this. It's the opposite, okay? That leading coefficient, that's like our A. Remember how our A would flip across the x-axis? Okay? If it's even, it's going to look kind of like this W's. And if it's even and the leading coefficient's negative, it's going to look like this. Now, yes, a lot of y'all, for the 5 people that's paying attention, some of y'all have the who farted face because you're trying to understand. I totally get you. But here's the deal. In today's notes, I actually have it set up like I'm going to have it on the test. Wow. So let's look at this. All right. Here we have this function. The first thing we have to do is put it in standard form. Okay. So we got to look for the highest exponent. All right. So we have -7 to the 6th. Okay. There's no fifth. So the next one would be -5x to the 4th plus 7x to the 3rd plus x squared, and then minus 9x plus 2. Okay, that's kind of gross right there. Now, that's the first part. Okay. Now, granted, yes, that was a very long one. Okay, nothing really combined. We're going to look at that later. All right. Now, the degree, what is this number right here? 6. So it's of the 6th degree, and it is a poly because there's more than 3 terms. So this is a poly. Okay. Now, is the degree even or odd? It's even because 6 is an even number. Now, when it says the LC, that's the leading coefficient. What is this right here? This is negative. Okay. So, since the degree is even and the leading coefficient is negative, on your chart, you would actually use this one right here. And basically, this is what it's saying. On the left, which is over here, f of x is going to negative infinity as x is going to negative infinity. Okay, basically what it's saying, as you go more to the x in the negative fashion, your y's are going to go also to the negative fashion. Okay, all right. On the right side of the graph, that's this over here, f of x, this is our y value. Anytime you see f of x, that means our y value goes to negative infinity as x gets bigger. Well, that would make sense, okay? It goes, as long as our x's get bigger, it opens down and stuff like that. All right. Now, I like having the chart on there that had all 4 of them so you could see it. Some people had to see it. Some people may have a different way of doing it. That's fine. But somewhere in between, it's going to work for everybody. Now, this is actually an example problem of something that you would have on the test. Okay, notice it covered a whole bunch of stuff. It covered standard form, degree, doing the terms, and then this right here, excuse me, is actually what we're learning today. Okay, now I've had some people that says on the left as X will go down as Y goes left or something. I know I've heard it different ways and it's okay. All right. So that was one of them. Did I lose you already? Did you just give up? Okay. All right. All right. So that was one problem. Okay. That was one problem with lots of stuff with it. Okay. And now I'm just going to move on. Just kidding. Let's do some, we're actually going to look at the rest of them that are set up just similar. So we hopefully get a better understanding. Okay. All right. So let's look at this one. First, we need to put it in standard form. Well, it looks like these two we can combine, correct? So we have a 3x to the third minus 4x to the third, which gives us negative 1x to the third, okay? And then these two we can combine. Well, we have 6x minus 3x. Well, that would just be plus 3x, okay? So we have the standard form done. You don't have to put the negative 1 right here. If you have to put it for you to understand it, that's fine. I do not care. Okay. All right. The degree. What is this little number that's in the front? 3. It's the third degree. It's a cubic. Okay. All right. Number of terms. How many terms do we have? Yeah, it's a binomial because there's 2 terms. Now, is our degree even or odd? Odd. Now notice, look, for those that's paying attention, you may have seen that, oh, there's points actually put in for these things. Yeah, you actually get points for answering this because you have to know this concept to get this part right. Huh? Okay. Is the leading coefficient positive or negative? Negative. Okay. So because our degree is odd and our leading coefficient is negative, it's going to actually go with this one in the chart. That means that our f of x goes to positive infinity as x goes to negative infinity. That means that our y is going up as our x goes left. And on the right, our y goes to negative infinity, goes down as our x goes all the way to the right. Okay, now, usually students will actually, and I'll show a version of this where that chart is kind of condensed and people use that. Okay. Now, that's our second one. Hopefully a little bit better. Okay. All right. It's getting some people. All right. Number 2. First thing we need to do is put it in standard form. Well, that would be minus 2x to the fourth minus 5x and then plus 1. All right. The degree. What is the degree of this? 4. How many terms do we have? Trinomial. It's 3. Very good. All right. our degree is even or odd? Even. And our leading coefficient, is this positive or negative? This one happens to be negative. Okay. There's a couple people just giggling left and right, and I do not know if it's actually about what's going on. I really doubt it. They might be sisters in this class. Who knows? All right. So, if our degree is even, okay, our y goes to negative infinity as this goes left, and this also goes to negative infinity as x goes right. Okay, so now I'm hoping that as we're doing this, some of that chart stuff makes a little bit more sense. I cannot say, hey, everybody's got it now. No, I'm not that type of person. Okay, exactly. All right. What? What's the question? All right. This is where a lot of people get confused with it. This f of x is basically that's our y values. Okay. So it's saying on the left side of the graph, our y values go to negative infinity as our x values also go to negative infinity. Okay. On the right side, it says our y values go to negative infinity, which is down, as our x's continue on. Okay. That's what it's saying. All right. Now, number 3. All right. This looks like 7x to the 6th minus 3x to the 5th. These actually combine to give us negative 8x. Okay. So what's our degree? And our terms is a trinomial. Our degree is even, and our leading coefficient is positive. Okay. So that means, note u, this is what it looks like. Okay. Our f of x or our y values goes to positive infinity or goes up as our x goes to the left or to negative infinity. However, if somebody tells me up and left and down and right, I know exactly what you're talking about. Okay. Some people would see that. And then on the right side, our f of x or y's also go to positive infinity as this goes to positive infinity. On the left side, what color? Okay, the top blue one, that's this left side of the graph here. That means our y values go up as the x values go to negative infinity to the left. Remember, there's two infinities. There's a positive and a negative. Yeah. I've actually had, like, I've seen people this type of chart in like 16 different ways. It's just, you could probably Google end behavior polynomial functions online, and you can get like multiple different versions of this chart, and you could find the one that works for you. Okay, or make one. Okay. All right. So not so bad, but here's what's funny is actually when we're doing this actually kind of knocks out like 2 or 3 things. Okay, standard form, degree, terms, and then all this stuff. That's why I kind of like it, because one problem we can actually cover multiple standards at the same time. Okay. All right. Now, here's the deal. And I was actually talking about this to my advisory class. They're like, oh, I don't like synthetic division. All right, here's the deal. There are some people that you are actually going to have to do this as a long division thing. And every time I mention long division, I have students that has like, all I remember of long division is sitting at the kitchen table being yelled at by one of my parents because I cannot do it. Okay. So, and here's the thing. It's a path. You have one that has PTSD and one that seems a little bit easier. People are going to take the one that's a little bit easier. All right. So, the first thing we do is take the opposite number of the binomial and put it in the timeout box. So the binomial is this one right here. This has -5. What's the opposite of -5? 5. So we're going to put 5 right here in the little timeout box. Wow, and somebody actually provided you the timeout box on your notes today. Okay. Second, you're going to put the coefficients across the top. Now, the coefficients are the numbers that's right here. Well, our coefficients are 1, 1, and 12. Okay. So now I was typing this out, and as I was typing it Friday afternoon, I was like, it ended up looking like a paragraph, and I was like, no, we're just going to just say follow Mr. J along. All right. So we're just going to drop this down, whatever number this is. This first one always goes down right here. Okay. Now, pay attention to what's about to happen. We're about to say 5 times 1 and then put that answer right here. Okay. So what is 5 times 1? 5. Okay. Now, in this column right here, what is 1 plus 5? 6. Okay. Now, all right, we're going to do the same thing. We're going to say 5 times this and put that answer right here. Okay. So what is 5 times 6? 30. Now, these both happen to be positive, so positive and positive we add. Okay, so what is 12 plus 30? 42. Okay, believe it or not, our division stuff is done. Now all we have to do is write it in its form. Okay, so we started with the x squared, right? So, and we divided it by 1x. So if we have 2 x's and we take 1 away, how many are we left with? 1. So this actually starts at 1x plus, well, we're out of x's, 6. And then we still have this number. So what do we have? It was have something left over. It's a remainder. Remainder of 42. And that's actually our answer. Now, you could write it like this, or you would see it like this, x plus 6, remainder 42. Either one of these is acceptable. Now, if you're sitting here thinking, wow, that was a lot going on, but it seems kind of simple, but yes, that was one problem. Okay. If everybody gave up after the first problem, let me tell you, y'all would not have smartphones or internet or possibly toothbrushes. Huh? Uh, yeah, probably mechanical pencils or mass production of clothing. Now, that was just one problem. Let's do a couple more. Are you seriously you're sitting there being upset that you don't understand the first problem and I say, "All right, let's do a couple more." And you're like, "No." Hey, why is t-shirt short for Tyrannosaurus shirt? Because of the short arms. Yes, laugh at that. That's hilarious. Okay, so let's do the same process. First thing we do, we take the opposite of this number and put it in the timeout box. Now, unfortunately, whoever made your notes did not provide the timeout box and stuff for you here. Aww, so sad. Okay, so what's the opposite of minus 3? 3. Okay, now the coefficients. What's the number in front of x squared? 1, and then 6, and then another 1. Okay, now we drop this 1. That's just the rule. Okay, now what is 3 times 1? 3. It goes right here. Okay. What is 6 plus 3? 9. This is not calculus right here. Actually, not really. Well, it just depends on what you're doing in calculus at the time. Huh? Do I calculus? Uh, I haven't taught it, but I probably could. Mhm. Can I move up? Okay, so over here, what is 3 times 9? 27. And then we add this, we get 28. Now, when we're writing our answer, we started with the x squared, so our answer is always 1 less than that. So our answer is actually 1x plus 9, remainder of 28. Yeah. Wow. Yeah. This, listen, I could show you. I'm not going to record it. I'm not going to record me trying to do long division with this stuff because I would not want to do that. I am more willing to dye my hair blue in a mohawk if I get 1,000 subscribers than show you how to do long division. It's like maybe 90. Yeah. Okay. All right. So fake dreads? Like a Rasta man. All right. So let's look at number 5. All right. Shh. So first, what's the opposite of +2? -2. Okay. Now we have 2 and -1 and a +5. Okay. So we drop down the 2. All right. What is -2 times 2? -4. Very good. Okay. Now, -1 minus 4 is actually -5. Okay. -2 times -5 is 10. 5 plus 10 is 15. Okay. We've got our numbers. Now we need to write it in the right form. Okay. Starts with x squared, so my answer is going to end up being 2x minus 5, remainder 15. Now, the original handout that I think I posted when I was out actually has stuff where it does this and has arrows and all that kind of stuff. It's like, that gets a little bit messy. So let's not do that. Unless you happen to be one of those people with like a 16 pack of multiple colored erasable pens. I don't know. All right. So, shh. Anyways, we are 3 problems from being away. I know some of y'all are multiple problems from being normal. So let's just keep going. Okay. So, number 6 looks a little bit different than some of the other ones. Okay. Yes, there are 2 binomials. So that actually, so shh, normally we would have, it would be x squared plus something x plus 25. Well, we don't have an actual term right here. Okay. So what would actually be our coefficient? What would be in front of the x right here? Okay, please understand there is with nothing is supposed to be there, it's not a 1. Okay, when nothing is supposed to be there, that's a 0. All right, so our numbers across the top will actually go 1, 0, 25. It has to, this has to be in standard form, and we have to account for every, like if this started with x to the 6th, we have to have x to the 6th, 5th, 4, 3, 2, 1, 0, all the way down. Okay. All right. So we drop this first one. Pew. Okay. What is 5 times 1? 5. Okay. What is 0 plus 5? 5. And 5 times 5 is 25, which would end up giving us 50. So our actual answer well, some of the math that y'all do is very unique, kind of like, hey, there's nothing there. Let's just write a 1 or a 7. Or I've actually seen it on some people's tests. They're like 2 plus 2 is 8. I mean, just there's some math bullying going on in my classroom. They're picking on each other. It's kind of funny. All right. That was number 6. Let's look at number 7. I'm going to poke both y'all's eyeballs out so y'all can't look at anything. So, huh? It's fine. Shh. Okay, look at this problem here. We have x to the third, and then it goes to x. That means that we're missing an x squared term. Oh, okay. Notice here how it went x squared to our constant, and we had to put the 0 right here for the x term. Okay. This starts to x to the third. Then it goes to minus 2x. That means there's not an x squared term. So we had to put a 0 x squared, so when we do our coefficients, it works out correctly. All right. Ops. Okay, the question was in number 4, there was a x squared plus 6x. Why was there not a 0 there? What is that number? Does this go, look, notice I said that this binomial has to go highest all the way down to a constant. Yes. Oh, all right, 1 and then 0 and then negative 2 and then 8. All right, so negative 2 times 1 is negative 2. Listen, when y'all don't answer it, it makes me get really worried. Okay. Now this one's even harder. What 0 minus 2? Negative 2. Okay. All right. What is negative 2 times negative 2? 4. 4? Like it's a question? Like we're not real sure? Okay. All right. Negative 2 plus 4 is 2. Mm-hmm. And then negative 2 times 2, negative 4. Ho, ho, ho. Remember, use the calculators is highly encouraged. All right. 8 minus 4 is 4. All right. Now, when we're writing this, we started with x to the third power. So our answer should be 1 less than that. So it should be x squared. So this would be 1x squared minus 2x plus 2, remainder of 4. Okay. So that was number 7. We had another one where we had to count for the term not listed. Let's look at number 8. Now, for some odd reason, it did this plus minus right here because stuff hates me and I was trying to do it Friday afternoon. Please just change that to a plus. I don't know. I just heard it sound like Scooby and Shaggy. All right. So let's look at these powers. This goes x to the 4th minus 12x to the 3rd plus 18x squared. There's not a x to the 1st power. So what do we have to put in here? A 0. Now, if we look, our powers go 4, 3, 2, 1, none. All right. The opposite of plus 4 is negative 4. And then we put our coefficients. So 1, negative 12, 18, 0, and 10. I don't know. 12. All right. You're still lost of why we had to put the 0 in there. Somebody said, does it have to count down like 4, 3, 2, 1? And I was like, okay, look, watch the bouncing, smiling face. 4, 3, 2. So it has to go 4, 3, 2, 1, none. Okay. So negative 4 times 1 is negative 4. Negative 12 minus 4 is negative 16. Okay. Negative 4 times negative 16 is positive 64. Let's see, 18 plus 64 is 82. Whew, this is going to get big quick. Negative 328. Yeah, negative 328 times negative 4 is, hang on, I got to grab all this. And then 1, 3, 1, 2. So this should be purple. And this should be 1, 3, 2, 2. Okay. Now, if we started with x to the 4th in our original problem, our answer has to start with 1 less than that. So that's x to the 3rd. So we have 1 x to the 3rd power minus 16 x squared plus 82 x minus 328 with a remainder of 1,322. Now, when we get weird numbers like this, you definitely know that Mr. Jeffries was just typing in numbers into the problem without actually copying down from somewhere. I was just like, hey, yeah, I've been found guilty of just, slacking, just typing in numbers. It used to be really funny at the house when all the kids were there, and I was like, yeah, I would just I would just ask for random numbers, and they're like, "What do we do?" And I'm like, "Making test." So they would just give me random numbers, and then come the test time, people were like, "Why are these numbers so weird?" I'm like, "I don't know." Yes. Anyways, and we're gonna look at our last one. No. All right. So let's look at our problem. This goes 3-1. So what are we missing? An x squared term. Oh my gosh. Never mind. Nope. We're going to keep moving. Nope. 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 Keep moving. Okay. So 2 times 2 is 4. 0 plus 4 is 4. 2 times 4 is 8. Negative 15 plus 8 is negative 7. 2 times negative 7 is negative 14. 23 minus 14 is 9. Now, we started with x to the third power, so our answer should be 1 less than this. So this should be 2x squared plus 4x minus 7, remainder 9. Now, if you would like extra practice with this, there is that Schoology assignment that was for last Thursday that you could work on. Some people are like, oh, there's Schoology? I'm serious. When I actually looked that some people had logged into it, I was really surprised that you knew it existed. Not everybody, just some people. All right. And that's all for today from Mr. Jeffries. Don't forget, hit the like, hit the subscribe, hit the bell. Good stuff, good things. Roll Tide.